Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to graph inverse trig functions. Of course, there is a PDF file version on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, to sketch y is equal to sine inverse of x. So let me just graph y is equal to sine x first, okay? So you understand a little bit better. So we have y and this is x, and this is, let's say this is pi over 2, this is pi, and then this is 1, this is negative pi over 2, this is pi. Let's just sketch from negative pi to pi. That will do, okay, for sine. And this is negative 1. So we know that sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of negative pi over 2 is negative 1. And sine of negative pi is 0. So the graph is like this. And this is y is equal to sine of x. So y is equal to sine of x. Now, in order for the inverse function to exist, so we need to pass the horizontal test. In another word, we need to have one-to-one functions. And this is many-to-one function at the moment. In order to have one-to-one functions, we need to restrict the domain. So if we restrict the domain from negative pi over 2 to pi over 2, so that will becomes one-to-one functions. So the graph will be like this. So this is y is equal to sine of x between negative pi over 2 and pi over 2. So this will be one-to-one functions. So we can find the inverse of this. Now to graph the inverse of this, let me just draw the axis first. And we have x here and this is y here. Now at this point here, this is pi over 2, 1, right? So for inverse functions, we just switch between y value and the x values. So pi over 2, 1, the inverse of this become 1 and pi over 2. So let me just write 1 here. And this is pi over 2. And this is 0, 0. So it's switch around, still the same. At this point here, we have negative pi over 2, 1 negative. So it switch around, becomes negative 1 and negative pi over 2. So negative 1 here and negative pi over 2. So this is negative pi over 2. So there you go. So now to graph it, we just connect these points together. But remember, for y is equal to sine x, it's curved to the x-axis. So for inverse, instead of curves to the x-axis, we curve to the y-axis. So it'd be like this. So there you go. So this is y is equal to sine inverse of x. So this is the inverse sine of x now. So please remember, we need to know the domain and the range of the inverse, okay, trig. So if you think about it for these functions, so the domain of this function here is between negative pi over 2, pi over 2. That is the domain. And inclusive, of course. For the inverse functions, the range of the functions, it becomes the domain of the inverse function. And the domain becomes the range of the inverse. So the range for this is we can either look at the graph of inverse functions or we can just look at the domain of the functions. So the range for this is from negative pi over 2, pi over 2. Inclusive, okay? Remember that for me. And for the range, so for the range of the functions, so we have negative 1 to 1, okay? Range is the restriction of the y value, remember that. So therefore, this will become the domain of the inverse functions. So therefore, the domain of this inverse sine is become negative 1 to 1. Otherwise, of course, you can just look at the domain of the inverse and you can see that, okay? So Please keep that in mind, okay? Second one, let's sketch y is equal to cos inverse of x. So to graph this, let me do the same process again so you can understand a little bit better, okay? So let me just sketch y is equal to cos of x first. So let's just sketch between negative pi and pi, okay? That would do for this exercise. So this is y, this is x. So this is pi over 2 pi. This is 1, negative 1. This is negative pi over 2. This is pi. So cos of 0 is 1. Cos of power 2 is 0. Cos of pi is negative 1. And we know that cos of negative pi over 2 is 0. It's just the same pattern. So let me just get this first. So there you go. This is cos of x. Now to work out inverse cos of x, of course, we need to have one-to-one functions. So in another word, it must pass horizontal test. So if you think about it, so if you draw a horizontal line here, we cut the curve twice. So you can see, cut this and this. So therefore, inverse function won't be exist, okay? So therefore, we need to restrict the domain. So it become one-to-one functions. So we can restrict the domain between 0 and pi. So that will become one-to-one functions. So your graph will be look like this, okay? So now it passed the horizontal test because it is now one-to-one functions. Now to get the inverse cos of x, so we know that this point here is 0, 1. So it becomes 1, 0. So let me just draw the axis first. So this is y, this is x. So this point 0, 1 now becomes 1, 0. So let me just write 1, 0 here. So this is 1, 0. And this point here is power 2, 0. It becomes 0 power 2. So this is 0 power 2. Let me just write power 2 we do. And then this point here is pi and negative 1. So it becomes negative 1 pi. So negative 1 and pi will be here. Okay. And now we just plot these points together. So let me just extend the graph a little bit longer. So this is y and this is pi. So to graph this, so remember for cos x, it curves to the x-axis. Now for inverse cos x, instead of curve to the x-axis, it curves to the y-axis. So please keep that in mind, okay? Very important, because otherwise it'd be wrong. So there you go. So this is y is equal to cos inverse of x. So the domain of this, let me just write the domain of cos of x first, okay? So cos of x for the domain of the functions is between 0 and pi and inclusive, of course. So therefore, the domain now, it becomes the range of the inverse. So that is between 0 to pi. And for the range for the functions is between, you can look at the graph here, so negative 1 to 1 and inclusive, okay? Don't forget. So therefore, the range of the functions becomes the domain of the inverse functions. So that becomes negative 1 and 1. So please keep that in mind for me. The domain of the inverse functions for cos inverse is between negative 1 and 1. And the range becomes 0 and pi. Okay, keep that in mind. Let's graph y is equal to 10 inverse of x. So to sketch y equal 10 inverse of x, let me just do the same process. Okay, let's graph y is equal to 10 of x first. So this is x and this is y. So let's just sketch between negative pi to pi. Okay, so this is pi This is negative pi. And of course, we know that halfway between is pi over 2. Now remember y equal tan of x. So that is exactly same as sine x over cos x. And you know that we cannot divide by 0. So for cos x is equal to 0, that is pi over 2. So it won't be exist. Okay, so therefore the vertical asymptote is pi over 2. Similarly, this is negative pi over 2. Cos of negative pi over 2 is 0. So you cannot divide by 0. So the asymptote is here. And halfway between is pi over 4. So tan of pi over 4 is 1. Let me just write 1 there. And then tan of negative pi over 4 is negative 1. So let me just write negative 1 here. So for tan, it's just like this. So this is y is tan of x. So for pi, it's the same. We're just repeating it like this. So that is tan. So in order to have inverse tan, we need to restrict the domain to becomes one-to-one function. So it passed the horizontal test. So to restrict the domain, so we can restrict between negative pi over 2 and pi over 2. So that is the restricted domain in order to have inverse tan of x. Okay, so that, let me just clear this. That would be like this if I restrict the domain. So now let's just sketch inverse tan of x. So this is y, this is x. So for inverse tan, so we can see the vertical asymptote is pi over 2. Now the inverse for that, it becomes pi over 2 here. That becomes the horizontal asymptote. So that becomes horizontal asymptote. And for the negative pi over 2, the vertical asymptote here, the inverse for that becomes horizontal, okay, asymptote. So negative pi over 2. So there you go. So now this point here is pi over 4, 1. Now it becomes 1 pi over 4. So this is 1 here, pi over 4 is halfway. And this point here is negative pi over 4, negative 1. Now it becomes negative 1 pi over 4. So negative 1 here and pi over 4 is halfway between. So there you go. So now I just sketch it. 0, 0 is the same because switch around, still the same. Okay, keep that in mind for me. So don't forget, we need to curve to the x-axis because for tan of x, it curves to the y-axis. So therefore, we inverse that, okay? It becomes curved to the x-axis. So don't forget. So it's like this. That is. So there you go. This is y is equal to tan inverse of x. So let's write down the range and domain. So the domain for these restricted functions is between negative pi over 2, pi over 2, and exclusive, okay? Because you cannot have tan of pi over 2. So this becomes the range for the inverse functions. Otherwise, you can look at the inverse graph and you can just write down the range and the domain, okay? So the range for this is between negative pi over 2 and pi over 2 and exclusive, okay? So that's why we do normal brackets. And the range for the functions, let me just write this down, is between negative infinity to positive infinity. Because there's no restriction for that. So that becomes the domain of the inverse functions. So between negative infinity to positive infinity. So there you go. This is how you sketch the inverse trig functions. And thank you so much for watching. Bye.